So what I'm going to be talking to you guys about is centripetal force and acceleration. And so this unit is all about circles. So what I want to start off talking to you guys about is circumference. What circumference is this distance it takes for an object to complete one full revolution around a circle, meaning go one full time around a circle. And period is the time it takes for it to do that one complete revolution around a circle. So what that means is that this blue dot over here, it would go for it to complete one full revolution would be for it to go around the whole circle and then stop at the spot where it is right now. So the beginning is the end. That's basically what that means. And so period is, I don't know if I mentioned that earlier, but it's the time it takes to complete one full revolution. And the unit for period is a capital T. And for circumference, the formula for that is 2 times pi, which you can abbreviate as 3.14, and then times r, which is the radius, and that's little r, lowercase r. And so you can see that in this circle in the bottom right, speed is the magnitude of these velocity vectors. And so you guys remember from the vector unit that what a vector is, right? So you can see that it labels them V1, V2, V3, V4. And so speed is the length of it, the magnitude. And so you can see that all of them are of equal length, which is why it's said that speed is constant. And so don't be fooled though, because the speed is constant, that does not mean that the velocity is constant. Velocity is said to be a vector, and the speed, like I said earlier, is constant, but the direction is constantly changing. So you can see how all the arrows are pointing in different directions. So one, as the velocity is going, it's constantly changing direction. The magnitude is staying the same, but the direction is constantly changing. And so for these reasons, that's why it's called tangential velocity, since tangent means a straight line that touches a curved surface at a point. And in this image, the velocity is touching the surface of the circle at a point. And so to continue on, so you can see that in this picture, the radius is half of the diameter, which the diameter is the full length from one side of the circle to the other side, and the radius is half of that. And so in this picture, you can see that the person is pulling, using a string, he's pulling the ball in a circular motion around in a circle, basically. And so you know that tension is drawn opposing the object away from the object. And so that's why the arrow is drawn towards the person. And so if an object is moving in a circle, then the direction of the velocity is constantly changing. And I mentioned that earlier. And remember that if the velocity is changing, we have acceleration. So as this ball is moving around, its speed is staying the same, but its direction is constantly changing, because you see it's going to be changing, like where it's positioned, it's going to be changing as it moves around constantly. And so acceleration is always pointed towards the center of the circle. So where there's acceleration, there is also a net force. And so what I mean by that is over here. So the acceleration is pointed towards the center of the circle. And so that means that there's a net force, because you know that when there's acceleration, there's also a net force, because it's not constant. And so this acceleration is not just called acceleration, it's called centripetal acceleration. And so, where is this? Centripetal. Okay, so I wanted to mention this before. So centripetal force is a net force, and that's why it's drawn, well, you don't draw it on a circle, but it is towards the center of the circle. And that's why in this case over here, the acceleration is the centripetal force. And so centripetal means center seeking, which is why the acceleration is drawn towards the center. And so I would like to say that anything towards the center is considered your centripetal force. And so in this situation, the tension is towards the center. So it's the centripetal force. And those are some formulas we'll be covering. And so over here, all of these formulas are very important. So I said earlier that the acceleration is pointed towards the center of the circle. And so whatever's pointed towards the center of the circle is the net force. And so acceleration is equal to the net force, and the formula for acceleration is velocity squared over the radius. And so since the acceleration is the net force, you can equal the net force. You can say that the net force is equal to the acceleration. And so I mentioned earlier that the acceleration is the centripetal force, and centripetal force is Fc, and you see that over there. It's the little c. And so the net force is equal to Fc because the acceleration is pointed towards the center, and the acceleration is equal to the net force, which is also equal to Fc, which is also equal to mv squared divided by r, since that's what acceleration is equal to. And so since the acceleration and the force are directly related, the force must also point towards the center. And like I mentioned earlier, that's why it's called centripetal force. And you never, ever draw centripetal force on a free body diagram because it could be represented by one or more forces. So some formulas that I'd like to cover with you guys is, so I mentioned that, I'm not sure if I mentioned earlier, but frequency is the number of rotations or revolutions per unit time. And frequency is represented by, little f, lowercase f. And so it is very important to know that the period and frequency are reciprocals. So that means that capital T is equal to 1 divided by f, which is, in other words, period equals 1 divided by the frequency. And also that means that frequency is equal to 1 divided by the period, or f is equal to 1 divided by t, capital T. And so the unit for frequency is hertz. And velocity can be called linear or tangential speed, the linear or tangential speed. And I'm pretty sure that's referencing, and I'm pretty sure you're getting a flashback from when I said velocity can also be called tangential velocity. That's where the tangential speed comes from. And so the formula for velocity is 2 pi r divided by t, which is basically the circumference divided by the period. And so now I'm going to be talking about the formulas for centripetal acceleration and centripetal force. So the formula for centripetal acceleration is AC, which is, where is it? Over here on this slide, you see that AC is equal to velocity squared divided by r. and that's the formula for centripetal acceleration. And where, r is equal to the radius, v is equal to the velocity. And on the left, you can also see the formula that I said for velocity, which is 2 pi r divided by t. And so, like the regular acceleration, the units for centripetal acceleration is m over s squared, or m over s meters per second squared. And so the unbalanced force that gives objects traveling in a circular motion acceleration is centripetal force, sorry. And so centripetal force is always directed towards the center of the circle. So FC is equal to, let me go where it says it on this slide. So here it is. So it says that FC, on the second row, it says that FC is equal to mv squared divided by r. And that is also equal to, ma, which is mass times acceleration. And this really all just connects everything together. You really need to memorize these formulas and take time to really understand them and what they mean, because this will help you solve a lot of problems, because this connects together a lot. It can help you solve for velocity or mass or radius, and you can substitute this in for a lot of stuff. So remember, centripetal force, which is FC, is equal to mv squared divided by r, which is equal to mass times acceleration, which is equal to the net force. Okay, so, and the unit for centripetal force is newtons.
Okay, so the problem that I'm going to be doing with you guys is a circular motion problem as it goes with the topic. So a 1.5 times 10 to the third kg car is moving around a circular track at 15 meters per second and is being acted on by 700 newtons of frictional force. So what this problem wants is, what is a track's radius? So the first thing that I do is I look to see if there's any conversions that I need to deal with. I have kg over here, so that's fine. Meters per second, no, okay, and then newtons. So the first thing I'm gonna do is draw like an image representation. So it's moving around a circular track at 15 meters per second. And so I can say that the car could be over here, right? And so I know that force normal will be acting on the car. And then I also know, and I'm gonna label that, and I also know that gravity, mg, would be acting on the car too. So, and I know that those two forces are balanced because the problem doesn't say anything about it. But what I know that's unbalanced is the frictional force. And I know that that's towards the center, right? And there was a similar problem like this in the notes. So I know that frictional force is towards the center. And so what I like to do to organize myself, now that I know this, is, wait, let me actually, so whatever's towards the center, like I said, is the centripetal force. And so this is also the centripetal force. And so, let's see. So I like to organize it into my Fy and Fx, what like the forces acting, the forces in the y direction and the x direction. So I'm going to do that right now. So the forces that are acting in the y direction is Fn and mg, the cars over there, and those are balanced. So I'm going to equal those to each other. And so for the x direction, it is unbalanced, and the only thing that's acting on it is centripetal force slash force friction. And so I would say that FF which is equal to F net. Wait, let me bring this down. So F net is equal to FF, which is equal to MA, right? So this whole thing is FF is equal to F net, right? So I could basically say that is equal to FF, which is equal to MA, right? And so I know that I'm trying to solve for what is the track's radius. And so then I have to look for a formula that has radius, right? So I remember, if you guys remember from the notes, I put this equation, centripetal force equals mv squared divided by r, which also equals ma, right? So since I know that the force of friction can equal mv squared divided by r, right? And so I know that the force of friction is a centripetal force. And I can then, okay, so I think I can then move everything to isolate r basically. So I can multiply by r over here, force of friction times r, and then that would equal mv squared. And so then I'll divide by the force of friction, cancel that out. The radius would be equal to mv squared divided by the force of friction, right? And so I know that. And so then now that I've isolated it, I can then plug in the numbers. And so I'll do r is equal to, plug in my mass, which is this over here. So 1.5 times 10 to the third as my mass, and then times the velocity, which they give me as 15 meters per second, which is 15, that would be squared, and then all over the force of friction, because it says it's being acted on by a frictional force of 700 newtons, so 700. And then if I plug all of that into my calculator, and if all of that is plugged into your calculator correctly, that will give you 482.14 meters, and that is rounded to the hundredths place. So that would be your answer.